previous class, we discussed about the AC circuit steady state analysis. So we studied the loop current method and also we studied node voltage method. So we studied for all the cases starting from dependent sources. We also studied super mesh, super node. Right. So now we'll move to the next topic. So that is power in AC circuits. Power in AC circuits. So in case of DC circuits, so how the power is formulated in case of DC circuits. If you know the voltage, right? If you know the voltage, if you know the current, so what is power P?
V into I.
V into I.
Okay. Or some other, if you have resistive element, so the power is I square into R or V square by R.
V square by.
So in case of AC, so you have varieties of powers. In case of AC circuits, you have varieties of power. So first we have instantaneous power. So first we have instantaneous power. Instantaneous power, right? We already know that. So these instantaneous values are usually denoted with small letters or lowercase letters. So instantaneous power P, so which is the product of instantaneous voltage into instantaneous current, which is a product of instantaneous voltage into instantaneous current. So this instantaneous power is power absorbed by the element at a specific instant of time. So it is at a specific instant of time. So it is denoted with lowercase letters. In other words, it will be P of t equal to V of t into I of t. Right. So let us assume that V of t is Vm sine omega t and I of t is Im sine or sine omega t. Right. If you assume that, so we have a resistive element, something like this. So this is V of t, and so this is R. So this will be I of t, right? So in case of resistive element, so both voltage and current are in phase. So both voltage and current are in phase. So if you try to draw these waveforms, so it will be like this. You have voltage here, and so your current here. Okay? So this is V of t, and this is I of t. So its peak value is Vm, so its value is Im. So how you will define P of t? So how you will define P of t?
Im sine square omega t.
So that is Vm sine square omega t. In other words, instantaneous multiplication of these two, right? So this is positive or negative? So this voltage is positive. So current is also positive. So that means how it will be? So Vm sine square omega t. So it will be something like this, right? Agree?
Yes, sir.
Okay. So what is the second negative of cycle?
Positive only, sir.
So both are negative, right? So that means the product is positive. So this is P of t. So which is Vm Im sine square omega t. So how to write this sine square omega t in terms of cos terms?
1 minus
Cos 2.
Im into 1 minus
So 1 minus cos 2 omega t whole upon 2.
whole upon 2, right? Agree?
Yes, sir.
Okay, so what is, if it is Vm Im by 2, that is the first term. So what is the second term? Vm Im by 2 into cos 2 omega t. So this is equal to P of t. So that means the overall waveform is something like this. Okay. So it is having two terms. So one is Vm Im by 2 term and Vm Im by 2 cos omega t. So this is 2 pi, right? Right. So this is pi. So that means we have 2 times the frequency. So that means if you have 50 hertz, right? So this will be 100 hertz, right? Agree? So this will be 100 hertz. So we have one average value or one constant value. So this, how to represent this constant value? So it is having some average value, right? This power is having some average value. It will be somewhere like this. So this value is Vm Im by 2. Agree? So this value is Vm Im by 2. So this overall thing is P of t. So that is Vm Im by 2 minus Vm Im by 2 cos 2 omega t. Cos 2 omega t. So that means the frequency, so which is the frequency, which is the double frequency component. In other words, it's a double frequency component. It's a double frequency component. So this gives you the instantaneous power, right? So usually instantaneous power means at particular instance, what is the power consumption, right? So that means there is no much meaning for that. So that's why, so we have average power, so which is denoted with capital P. So that means the, right, so we will denote with capital P. So this average power is the average of the instantaneous power over one period. So that is known as average power. So average power is the average of the instantaneous power over one period of time. Clear? So how to, so that means average that, how to average that? So we need to integrate that. So over one period of time, right? So how to do that?
CPDs.
So integration of, so capital P
CPDs.
equal to integration of P of t into dt. So what is its
By
limits are?
integral ds.
What is its limits?
0 to 2 pi.
0 to 2 pi means 0
0
to
to
time period.
2 pi, right?
Zero.
Yes, we are writing in t times dt, right? So it will be 2 pi by omega. Agree?
Omega. Yes, sir.
So what is its
Yes,
base?
Integral of
0
dt from 0 to 2 pi by
2 pi by omega.
omega.
pi by omega, sir.
So
Yeah.
that is its base, right? So this is how we integration 1
Yes.
by t integration of 0 dt. So p of t into dt. Agree?
Yes,
So
sir.
now this is equal to 0 to 2 pi by omega Vm sin omega t into Im sin omega t into dt. So that entire thing divided by 2 pi by omega. So tell me what is the answer?
Vm Im by 2.
Yeah, right. So it is Vm Im by 2. Vm Im by 2. So this can be written as Vm by root 2 into Im by root 2. So why particularly if you observe that, so this you left, if you are integrating this curve or this curve, right, you are integrating this curve, you left with only this one. So that is Vm by Vm Am into 2. So what's happening to this term is you are integrating with one full cycle, right? So you're integrating with one full cycle. So that's why it is 2 times the frequency component. So that's why its values become 0. Right? Its average value of this one is 0. Clear? So you have a
Yes, sir.
cosine component, so which is having 2 times the frequency, so that's why its average value is 0. Okay. So only you left with, so this constant term, so that is Vm Im by 2. So what is Vm Im? Vm by root 2?
So VRMS.
So
VRMS.
RMS into I RMS, or simply V into I, or simply V into I. So what is the meaning of average power? So average of instantaneous power, so that is V into I. So this is in case of resistor circuits. So this is in case of resistor circuits, or in other words, VRMS into IRMS. So this is as like a DC circuits. So DC circuits is also same, right? It's as like a DC circuits. So any questions here? Have any questions?
No, sir.
Okay, right. So next we move forward to the other circuit. So what if we have a pure inductive circuit? So how to calculate the power P, or capital power means how to calculate the average power P in a pure inductive circuit. So what is the current and voltage relation in inductive circuit? What is the current and voltage relation in inductive circuit?
Current lags
V
pi
is
by
into
2
T,
pi by
current
1.
lags by pi
This
by 2.
V of T is Vm sin omega T, right? So what is I of T?
Cos omega T.
Vm
So VM
sin omega T minus pi by 2, right? Good.
So there will be IM, sir.
Sorry, Im.
You can write Vm by R also. No?
Right? No Vm by R here. This is inductors L, right?
So here will be VM upon XL.
Yeah, Vm upon XL. Okay, that doesn't matter. We assume that is Im. Okay, right. So what is the next thing? So integration of 0 to 2 pi by omega into Vm sin omega T into Im sin omega T minus pi by 2. So what is the sin omega T minus pi by 2?
Minus cos
What is
omega
this
T.
thing?
Minus cos omega T.
Minus
Minus cos omega T.
wait. So into minus cos omega T into dt, so all by 2 pi by omega. So what is this value?
0, sir.
So this value is 0.
0.
Agree? So that means the power consumed by, right, the power dissipated in a pure inductor is 0. Right? The power or the active or the power dissipated or the average power dissipated in a pure inductor is 0. Right? Similarly, if you have a capacitor,
How do you get 0?
its integration is 0. The average power is 0. You're doing the integration, this value is 0, no? Right. So what kind of power it will be
Can
there
we
inside?
calculate
So that
instantaneous power?
we will discuss. Yes?
Instantaneous power.
Not instantaneous power, this is average power.
Can we calculate, sir? Instantaneous.
Oh, we can calculate that. If you multiply these two, that will gives you the instantaneous power. So that instantaneous power is present. So what is the instantaneous power? Sin omega t into cos omega t, right?
Yes, sir.
So Vm Im sin omega t into cos omega t. So minus Vm Im sin omega t cos omega t. That is present. So why exactly specifically 0 if you want that? So I will discuss Vm Im sine omega t into cos omega t. It is minus, right? So how to write this term?
In 2 omega t by 2, sir.
Sine
2 omega t by
2
2.
omega 2
2 omega t by
2.
Whole upon 2.
2, right? So that means we are taking the average of this one. So how this exactly will be represented? So this is Vm Im by 2 into sine 2 omega t. Agree? So
Yes.
how it will be if this is the voltage waveform, right? If this is the voltage waveform, so how exactly this power is there means, so it will be like this. Agree? So this is how we will represent 2 omega t, right? If this is sine omega t, right? So this will be sine 2 omega t. So this is 50 Hz. So this will be the 100 Hz. Agree? So when you are doing the average for this one over one cycle, average for this one over one cycle, what's happening is, so this value is 0 because the positive half cycle, both negative half cycle, both are 0. So that's why its average value is 0. This waveform is symmetrical, right? Okay. So this is the instantaneous power P of t. So this is the instantaneous power P of t. Okay. So instantaneous value is present, but the average value is, or average power is 0. So come to this case. So how it will be? So what is P here? What is the value of P?
0.
So here also
0,
its
sir.
value is 0, right? So if we do that, so its value is also 0. So only the difference is, so here the current value, so you'll get omega t plus sine omega t plus pi by 2 you will get, right? So rest of the things are same, or the procedure is same. So what you understood that, right? So the average power in resistive, so that is Vrms into Irms. But in case of pure inductive and the pure capacitive circuits, its value is 0. Its value is 0. But the instantaneous power is always present. So instantaneous power is always present. So next we will move to other circuits. So what if we have RL circuit? Say it is I of t. Right. So let us assume that so V of t is some Vm sine omega t, and I of t is Im sine omega t minus theta. So how do you define this theta? Based on the impedance of the circuit, so we can define this theta, right? We can define this theta, right? So what exactly the theta value here?
Tan
Tan
inverse
inverse XL by R.
XL
Tan
by R.
inverse XL by R, right? Good. Tan inverse XL by R. So that is immaterial for me. So we had already given that some theta. It is having some, it is making some angle theta.
XL by R, sir.
So XL by R, yeah. XL by R. Right. So now under this case, so how to calculate the, right? How to calculate the average power in this particular case? So so this is P, right? So how to calculate this P? Oh, sorry, this is P. So integration of 0 to 2 pi by omega. So Vm sine omega t into Im sine omega t minus theta dt, entire thing divided by 2 pi by omega. 2 pi by omega, right? So what is this value?
So Vm Im whole upon 2 into cos theta.
Yeah, correct. So it will be Vm Im by 2 cos theta. So we have other terms, that is Vm Im cos theta into 1 by 2 Vm Im cos 2 omega t minus theta. So that other term is present. So but that average value will be 0. Right. That average value will be 0. So we have other terms. If we decompose this into, we have two terms. So it is Vm Im by 2 cos theta. So that is the first term, minus 1 by 2 Vm Im cos 2 omega t minus theta. If you are multiplying these two, that is P of t. Right. So this one is, its average value is 0, but this value is some finite. So that is Vm Im by 2 cos phi. So how to write this? So we can write this, right? Vrms Irms into cos theta. So that's also known as Vi cos theta. So this is known as average power P. So Vi cos theta. So this is general formula Vi cos theta. So that is the general formula. In case of theta equal to 0, so that is resistive circuit, right? In case of resistive circuit, theta equal to 0. So in that case, P equal to Vi. In case of theta equal to pi by 2, that is a pure, what is the pure capacitive circuit, P equal to 0. So if theta equal to minus pi by 2, so the pure inductive circuit, so P equal to 0. So basically this theta is, right, basically this theta is the angle between voltage and current, the angle between voltage and current. So simply, so for example, we have 10 sine omega t plus 30 degrees. So this is the voltage, right? This is voltage. And similarly, we have current something like this, 25 sine omega t plus 70 degrees. So now tell me, what is the power P?
10 into 25 by 2 into
125 into cos 40, sir. 125 into cos 40.
So what is that? So Vm, so this is 10, right? So 10 into 25
By 2.
2 into cos
Cos
of voltage angle minus current angle. Right, this theta
Cos
is
minus 40
the
degree.
angle between voltage, right, and the current. Agree? So that means theta cos 30 minus 70 degrees. Agree? So what is that?
Sir.
So that is cos minus 40. So that is cos minus 40 or cos 40, both are same. Cos theta equal to cos minus theta, both are same, right? So that means it is cos 40. So 10, 25 by 2 into cos 40. So that is the active power P. Understood? So this theta is the angle between, or the theta is the angular difference between voltage phasor to the current phasor. Voltage phasor to current phasor. So we have to make sure that the reference, if this is sine, this must be sine. If this is cos, we have to convert this again into sine terms. So the units for this is watts. So units for this power, or this power is watts. The units for this power is watts. So this is the actual power. This indicates the actual power dissipated. This indicated the actual power dissipated, either in the form of heat, or either in the form of mechanical energy, or in the form of any other heat energy, or in the form of any chemical energy, or anything, right? So this will be dissipated in the form of other energy. So this is the actual power consumption, right? So this is the actual power consumption. So we have other thing. So that is known as apparent power. Apparent power. So that is denoted with S. So it is known as V into I. In other words, Vrms into Irms. So this is the product of voltage and current. So this is the product of voltage and current. So that is known as apparent power V into I. So we have this P equal to Vi cos theta, right? So this can be written as P equal to S into cos theta. P equal to S into cos theta. So units for apparent power is volt ampere. Volt ampere. The units for apparent power is volt ampere.
Can't we say watt only?
No, this is not watt, right? So this is not watt. So here the thing is that why this term is there, right? So when you are designing, there are some equipment, something like this, right? We have different electrical equipments are there, right? We have transformer is there and motor is there. Okay. So we have two things. One is the transformer and other thing is the motor. Right. So when you are buying the motor from one supplier, you must know so what kind of load you have to use. So for that specific load only you are using, right? Okay. So here the power drawn by this motor is known to you. So whereas if you are transformer, right? So you don't know so what kind of load you can expect. So manufacturer doesn't know what kind of load on the secondary side of the transformers that is going to be connected. It doesn't know, right? Because this power is, so this is the load, right? This power is always depending on this cos theta. So where this cos theta is coming, right? So this is coming from the load. Okay. Think that, so when you don't know what kind of load you are connecting, for example, transformer, so transformer will supply for industry or supply for home side or for street transformers are there. You know what kind of exact load it will be connected, right? So that's why these transformers are rated in volt amperes. These transformers are rated in volt amperes. Okay. Whereas these motors, you know exact what kind of load it's connecting, right? So that's why it is rated in watts, kilowatt. In other words, it's rated in horsepowers. Or it rated in, if it is a diesel or an engine, that means we rated in brake horsepowers likewise. So that is watts. Okay. So you know what kind of load it is connected, right? So that's why it is motors and other appliances. So they're usually rated in watts. So whereas in generators, for example, generators, if you know that 2 kVA generator. So what is this 2 kVA generator or 1 kVA generator? What is it meaning is kilovolt ampere. So kilovolt ampere. So this is the one. So that means the apparent power rating is given to you. So generators, you are aware of that generators, a 20 kilowatt 20 kVA generator in your home. When you are purchasing an inverter, right? So inverter is basically a generator, right? So that means 1 kVA inverter, 2 kVA, 10 kVA, or UPS. So usually UPS 600 volt amperes. You might have aware of this, right? So this is, you don't know, right? If you are buying a UPS, you don't know whether you are connecting a computer you will connect, or your some home appliance you will connect, or some mixer grinder you can connect, or anything you connect, right? So that's why, so actual power consumption is not known to them. Here the actual power consumption is not known to them. So whereas in this motor case, they know what kind of power consumption is that is there. So that's why it is rated in watts. So it is rated in volt amperes. That is the difference. Is clear? So all the power generators or the power, that means power delivery, especially transformers and other, so usually rated in volt amperes. So loads are rated in watts. Okay. So we have two powers, Vi cos theta, so P into Vi cos theta, right? P equal to V into sin theta. Agree?
Sir, means like what kind of circuit we are using, we don't know. That's why we are writing as volt amperes, sir.
Yeah, what kind of load you are connecting on the, for example, I've already said you have UPS is there, right? So UPS is there. So you can connect any kind of load, right? It may be computer load or it may be other load, or you can connect your home appliances, anything, right? So the actual power consumption, it may be depending on the load. So, but they don't know what kind of load it is connected. So that's why they are rated in volt amperes.
Okay, sir.
Okay. So, but the actual power consumption is depending on the load, right? So that means load. So that's why we have the term. So that is known as power factor. So this is the term. So that is known as power factor. So power factor is defined as power factor, simply power factor, PF. It is defined as active power divided by apparent power. Active power divided by apparent. In other words, P divided by S. Right, P divided by S. So it is VI cos theta by VI. So it will be cos theta. In other words, cos of angle between voltage and current. Cos of angle between voltage and current. So power factor, or the power factor of the source. So that is the ratio of active power by apparent power. So that is P by S, VI cos theta, or VI. So that is equal to cos theta. So that is the cos of angle between V and I. So in this particular case, what is the power factor?
So for minus 40 degree.
Cos minus 40 degrees, right? Not minus 40, cos of minus 40.
Yes,
Cos minus 40 degrees, or simply cos 40 degrees, right? So here, depending on this theta, right? So this theta is positive or negative, right? So when this theta is positive, what kind of load this theta is positive?
And capacitor.
Capacitive loads, right? So in case of negative, so this is for inductive loads. Right. So we have two classifications in power factor. So one is leading power factor and lagging power factor. So meaning is, right, so leading power factor, if the current leads the voltage waveform. So that means for capacitive loads. So we have power factor that is leading, and inductive loads, for example, in that case, the current is lags. In this case, theta is positive and this theta is negative here. In case of inductive load, the current waveform lags the voltage waveform by certain angle. So that's known as lagging power factor. So you have two kinds of power factors, leading power factor and lagging power factor. Leading power factor for capacitive loads, lagging power factor for inductive loads. Right? Because why? Because cos theta equal to cos minus theta, both are same, right? So but we must have some differentiation between inductive and capacitive things. So that's why we have leading power factor, lagging power factor. So we have another thing, that is unity power factor. Unity power factor. What is unity power factor means? Power factor equal to 1. So when it will be 1?
When theta 0 degree.
When theta equal to 0.
That's a resistor.
Right.
Resistive circuit.
So with theta equal to 0, resistive circuit, right? So that means for resistive circuit, it is unity power factor.
Sir,
For pure inductive circuit, what is the power factor?
minus pi by 2.
90, sir. 90. Minus 90.
0.
See here, you're understanding in the wrong way, right? So it should be cos of angle, not angle itself.
0, sir. 0.
0, right? So when you say that 0, you must specify it is leading or lagging. So I said that it's a pure inductive.
Lagging.
What is that? So
Lagging
0 power factor lagging.
Lagging, sir.
So minus
0
5.
lagging. So when you have power factor is there, so you must include whether it is leading or lagging. Similarly, if it is pure capacitive, so that is also 0 leading. So power factor is 0 leading.
Sir,
Yes.
sir, in the previous page, sir, the example which you give, sir, in that one, sir, it is, sir, it is capacitive circuit, right? So that
Yeah,
sine
it is
omega t.
capacitive circuit. So this is power factor is cos 40 degrees or cos minus 40 degrees leading.
Yes. And sir,
So this is
active power and average power are same.
Yeah, active power and average power are same. So this is one we are not discussing. This is known as active power or average power. Average power. Right. So why it is active power? So that we'll discuss now. So this is, you understood, right? So you have something like this. So this is voltage vector V. Okay. And this is the current vector I. Okay. So this is lagging and this is making some angle theta, for example. So this current can be decomposed into two components like this, right? So what is this component?
I cos theta.
Sir,
I
I
cos
cos theta.
This is I cos theta, right?
Yes, sir.
And this one is
I sin theta.
I sin theta. Right. So this current can be decomposed into two components. So these two components are known as active component. So which is aligned to the voltage axis or the voltage, and this is reactive component.
But current is a scalar one,
If you-
sir. How can you?
Like who said that current is scalar? This is a phasor only, right? Currents are phasors. Voltage and currents are phasors in AC circuits.
Okay, sir.
Okay. So if you multiply this voltage with respect to I, so that gives you VI cos theta, right? So this is known as active power P. So this is known as active power P, or the active component of current multiplied by the voltage, that gives you the active power P. Similarly, V into I sin theta, right? So this is reactive current. So I cos sin theta is the reactive current, multiply the current. So this is known as Q. So this is known as reactive power. So this is known as reactive power. So Q is VI
means
sin theta,
power left,
P equal to V. Hmm?
power left in the load, sir.
Power.
Left in the load means which is not used. Vi sin theta.
We will discuss that. Wait. Okay. So we had these two terms, VI cos theta term and Q equal to VI sin theta terms. So we have that S equal to V into I. So this is apparent power. So that particular one is the apparent power, right? So this P square plus Q square, or in other words, so it will be equal to S, right? Agree? Agree?
Yes, sir.
Yes, sir.
Yes, sir.
S equal to square root of active power square plus apparent power. So what is the meaning of this active power? Active power. So this is the real power, right? So active power or the real power is the rate of energy conversion or the dissipation taken as an average over one or more compute cycle, right? So this is the actual, right, or the real power or the real rate of energy conversion or the dissipation taken as an average of one cycle, right? So that is known as active power. And we have this reactive power Q. So this is the peak rate of energy stored or the peak rate of energy storage in the reactive elements, Right, we have the energy storage in the reactive elements, right? So we have reactive elements. In that case, we have some energy storage. So the peak rate of the energy storage in reactive elements, so that is known as reactive power. So this is the average rate of energy. Its average value is 0. For reactive power, its average value is 0. Right. So what this energy is happening is, this energy is continuously flowing into and the back of the circuit from the reactive components. So meaning is, so here we discussed here somewhere. So meaning is, right, reactive elements are, the power is 2 times the fundamental. This is fundamental, right? So here we have components, something like this. So here this positive power means the power is delivered to the load, right? So negative means the power is delivered from load to source. So this is load to source to load. Agree? Positive means source to load. Power flow is from source to load. If the negative power means the power flow is from load to source. Okay. So what's happening is, the power is continuously flowing from
Sir?
into and back up from the reactive components. Yes.
Sir, can you please again differentiate the source and load, sir? I didn't understand.
See here in reactive elements, what's exactly happening is, so here, so this is the power in the reactive elements, right? P of T. Agree?
Yes, sir.
Okay, so somewhere you have derived, right? What is that? So 1/2 Vm Im cos 2 omega t minus theta. So that is the reactive power, or the in what we say, that is the power or instantaneous power in the reactive element. So this is how we will represent, right? Agree?
Yes, sir.
So if this is positive, the power is positive. So what is the meaning? Right. So here some battery is there. Okay. Some source is there, for example. Some DC source is there, and you have some battery is there. Okay. So this is current is flowing in this direction. So this is VI, right? So this battery will take the energy, or it will deliver the energy.
Deliver.
If this is, for example, 10 amperes and this is 50 volts, right? So what is the power that absorbed by the battery?
So 500 watt.
500.
500 watt.
500 watt, right? Okay. So that means the power is positive, V and I. So both are positive, right? See, for example, if the current is flowing in the opposite direction. So now tell me,
So minus 500, sir.
minus 500
Minus
watts.
500 watts.
What is the meaning of this minus 500?
So means power has been drawn from source.
Drawn from the source.
From the load, sir. From the load.
Right. So here the battery is, right, the energy stored in the battery is delivering to the source. So this is the power flow in the opposite direction. That means from load to source. Agree?
Yes, sir.
Previous one, source to load. Positive means the power flow depending on the elements, right? And if your energy storage elements are there, the power flow can be from load to source or source to load. If the power is positive, it will be source to load. If the power is negative, it will be load to source. Same implies here, right? So in one off cycle, right? So in other words, so inductor is storing the energy in one quarter wave, and in the other quarter on 90 degrees, so it is giving the energy back to the source. Understood? So this average, so this is known as, right, so at what rate it is giving, so that gives you this VI sine omega t, so sine theta, VI sine theta. So this is known as reactive power. It will be simply like this. So we have this active power P here and reactive power Q here, and it will be S. So this is known as power triangle. So you know this P and you know this way. So what is the additional or the power? So that will be the Q. So it will not do any work like active power. So but it will continuously flow from load to source and source to load due to the presence of energy storage elements like inductor and capacitor. Clear? It is something like this. You have some coffee mug is there, right? So this is coffee mug is full, right? Something like this. You have foam here, and this is coffee here, right? So this is P, right? So this is Q, and this entire thing is S. Likewise. Okay? So this is the foam. So it will not do much, right? So this is the actual coffee, and this is the overall thing. S. Clear? So it will not, Q will not do any job, only the active power will do job. But thing is that some of the current is, additional current is absorbed or additional current is drawing to keep the energy storage elements active. So in one off cycle it will charge this, and the other off cycle it discharge, and it is feedback to the load. Okay, you will understand when you solve some problems and all. Okay. So
Okay.
depending on this theta, so we have this Q, VI, sine theta is there, right? If theta equal to positive means, what is that? So when theta is positive,
Capacitive.
Capacitive circuits.
capacitive circuits, right? So theta equal to negative for
Inductive
Inductive
circuits.
circuit.
inductive circuits, right? So now tell me, so Q is, so earlier it is sine theta equal to minus sine, cos theta is minus cos theta, both are same, right? So Q will be positive for when, and when will be Q will be negative.
So positive for capacitive and negative for
So
inductive.
this is for capacitive loads, positive. For inductive loads, it is negative. So reactive power will be positive or negative. So depending on the power factor angle, theta. So when the power factor angle is positive, that is for power factor capacitive loads. So in that case, Q is positive, right? Otherwise, Q is negative, right? So in other words, the rating for the units for this Q is volt ampere reactive. Volt ampere reactive. Volt ampere reactive. In other words, it is VAR, where kVAR, megavolt ampere reactive, VAR, so that is its unit. The thing is that it will not do any useful power, but the operation of all the inductive machines or the machines and all, or production of the flux for everything, so this reactive power is necessary. So how it is necessary, it may be learned in the your machines class and other classes.
Sir, examples means fans.
Yeah, in fans and all, right? So your capacitors are connected, right? Or inductor windings are there. So when the windings are there, so in that case, it will be right. The torque will be produced so that the machine will work. So how exactly it will work? So you will learn in the later classes.
Could you explain, sir, why theta is positive for capacitive circuit?
Hmm.
So why theta is positive for capacitive circuit?
1 second. Why? What you are saying? For
So why
capacitive
theta?
circuits, this theta is positive, right? Agree? This theta is positive, no? For capacitor circuits. Because it is leading, the voltage is leading, right? So that's why you have positive theta. So that's why you have Q is positive for capacitive circuits. So this theta is positive. So this sine theta is positive, right? So that means this entire thing is positive. Vi sine theta is positive. If this theta is negative, so in that case sine theta is minus sine theta. So that's why this Q is negative. So you have any questions here in today's class? You have any questions?
No, sir.
Okay, we'll stop here.